Awesome. Yay, so end of week 2, welcome. You've made it a fifth of the way through our final CS class here at Clark. So, I downloaded your repositories this morning from GitLab, and I will get those graded over the weekend with some feedback. Any lingering questions on PA1? We'll go through it in detail next week. But any burning issues you need to deal with now? Yeah, it is a bit of a bummer when the sequence ends, but it's also super duper exciting because you get to go on to even better things. The grading was vague on how many some errors were, but it's pretty clear if it works perfectly right, then that gets you the full points for that part. But yeah, it's subjective what some errors are. I mean, you could have one error, which is that, it crashes as soon as I try to do anything with your fraction class, right? That's a pretty significant error. You could have 3 errors where, you put a backslash instead of a forward slash or something, or you forgot the slash when you printed it out as a fraction or something like that. So yeah, it's a little subjective, but I think the grading in the end will be clear. Yeah, WSU is very exciting. That's true. That is a good definition of some. Yeah, I've tried to do very precise rubrics in the past, and I end up boxing myself into a corner, and I end up leaving students with a checklist of let's do these things instead of sort of the bigger picture of I want to make a fraction class that does these things, and that's really your only target, and that's also going to be reflected in your future classes at WSU or wherever, where it's basically make this thing and make it work, and that's what you want to shoot for. All right, so let's talk about PA2. So PA2 is due in a week. It's a complex assignment, but it doesn't necessarily have a lot of code involved in it. Okay, PA2 is all about thinking about classes and working with objects as instances of classes, and it's really an exercise in digging deep into this object-oriented mindset. And like in PA1, you were making fractions. So let's say you want to multiply 2 fractions. Well, one way to do that is to make a new fraction, and then set the top of it equal to what you want the top to be, and set the bottom equal to what you want the bottom to be, and then call the reduce method, right? Or run the reduce on those 2 values before you assign them. But if you're really thinking in terms of objects, a fraction is a whole thing. It has a constructor. It has a reduce method. It has a toString method, right? And so your alternative, instead of making a fraction and then adjusting the values, is decide what values you want the fraction to have, and then call the constructor. And that constructor makes the fraction, assigns the values, probably calls the reduce function, sets whatever flags if you have flags for not a number, and so on and so forth, right? So we really want to move into that mindset, and PA2 is going to really force you into that. If you go about PA2 trying to write C code in Java, it's going to be a nightmare, okay? But if you spend some time thinking about this in terms of objects and really sort of get your brain around how you're going to do this before you open up your editor and start writing code, I think you'll find that it's more straightforward and actually kind of fun. I am off by 1 in my disk space count. That's okay. All right. So programming assignment 2. So this is revisiting our word index program, which we did in 224 using associative arrays, we're going to do something similar here. So your general goal is make something so that you can feed a file, a plain text file, to your program, and it will produce a list of all the words in that file and the places where they occur in the input. So the position of each word. Okay. So stuff up here that I just said, right? You got to start this early. You got to give yourself time to think about it and go back and restart a few times as you move further into, you know, the mindset of objects. So you can't do it the day before. Stick to the command line. Don't use an IDE. We're not there yet, right? Stay on the command line. That helps you figure out the syntax and so on and so forth. Okay. So you're making a single class. Okay, and it's called indexer, uppercase I. And what you're turning in is just the code for that class. Okay, you don't have to turn in a main program, write main programs to test it. So similar to fraction. And yeah, position is basically word count. All right, so indexer has one constructor. You construct it just with no arguments, and it doesn't really do anything except whatever initialization you need to do internally. So you're going to construct an indexer. I'm going to call it ind, I-N-D, through this document. And it has a few public methods. The first one is called processFile. So you could say ind.processFile, and you give it the name of a file. Okay, this is just a regular Unix path name. And what this method should do, this does everything. Okay, so this will open up the file. It will read in from the file, and as it reads each word from the file, it will add it to this building index. Okay? Don't read the whole file into memory. Read a word, add it to the index, you're done with that word. Read the next word, add it to the index, you're done with it. Okay, so build the index as you're reading. And then when you're done, return success, true. Okay? The only time that this is going to fail is typically if you can't open the file. If it doesn't exist or you don't have permission to read it, then return false. Okay? But you're going to want to keep a flag internally to know whether or not you've successfully processed a file, because these other methods do different things depending on whether or not you've processed a file. Alright? Nothing gets printed from here. Okay, this just processes and it sets flags and it returns a value. If you can't open the file, don't print an error message, don't throw an exception, right? Just return false. If you can open the file, open it up, read in the words, build your index, close the file when you're done, and return true. But it's totally silent, okay? Once you've built an index, you have some other methods you can call. One is called number of instances. It takes a word and it tells you how many times that word appears in your file. Okay, so when you process the file, you're building a data structure. It's going to be a hash, and the entries in the hash are going to be linked lists. Okay, so you're building up this data structure. When you want to know how many times did a certain word occur, all you're doing is looking in your data structure that you've built. You don't go back to the file. Okay, so look in your data structure, and if the word is found, return how many times it's found. If it's not found, return 0. Edge case, if you haven't successfully processed a file, then this method returns -1. That's the error code, basically, saying I haven't processed a file. You're here now. That's what counts. All right. Another public method you have is called location of. And location of takes a word and it takes an integer. And it will tell you where that word is located in that file based on the instance number that you pass. So for example, if I say string hello, 0, it should tell me where the first occurrence of hello is. Occurrence is 0, right, which is the first. So hello, 0 should tell me the location in the file where the first time hello occurred. If I say hello, 1, that should tell me where the second occurrence of hello was. If I say hello, 5, that should tell me where the 6th occurrence of hello was. Okay, again, you're just going to read this out of your data structure. All the really hard work is up here in the process file. that builds your structure that has all of this other information in it, and these other things are just pulling data out of that data structure. So location of takes a word and the occurrence that you're interested in, and it tells you back where that occurrence is. Okay. Again, if you have not processed a file, this returns -1. That's a tag saying, hey, you know, it's not in there. If the word does not appear in the file, you also return -1. So if you look for a word that's not in there, return -1. If you search for an instance number that's negative, which makes no sense, right? Where's the -5th time this word occurred? That makes no sense, return -1. If the word only occurred 5 times and you ask for the 10th occurrence, return -1. So anything that doesn't make sense, return -1. Otherwise, return the location where that occurrence was found. Somehow we got to Bob the Builder. Okay. Number of words will tell you how many unique words are found in the index that you've built. Again, you're just reading that out of your structure. If you haven't built an index, return -1. You're seeing the pattern here, right? There's a toString method, and toString should print out the entire contents of your data structure. And your data structure is basically a hash table, and you can use the toString method of the hash table. So you really never have to write a print loop of your own. You don't need to pull things out of your hash and print them with print line and all this kind of stuff. You're really just going to use the print method in the hash table class, which is called a hash map. Okay, I'm going to require you to make a few private methods also. So one of them is going to be called cleanupWord. It takes a word, it returns another word. This does all of the pre-processing. Okay, so pre-processing means we want to change everything to uppercase and we only want to keep letters. So DON''T should become just uppercase DONT. Hello, comma should just become hello, no comma. Okay, we'll dig into these in a minute. So use character.isLetter to see whether this is something that you want to keep. If the character in question returns false when you put it through character.isLetter, then dump it. Alright, the other private method is called addReference. So addReference basically takes a word and a location and it adds that pair to your data structure. So if you find a word hello and you've decided it's stored at location 17, you should call addReference hello, comma 17, right? Or you know, the variables having those, and that should add that to your structure. Alright, you need one private field in your class named index. That's what's going to get initialized when you construct the indexer. Oh, this is going to be so much better than sed, though. Sed's always awesome. But this will be cool, too. Alright, so you got the high-level view, right? Let's talk about how we implement this. And the implementation, if you do it like this, right, it's very, very painless once you get things lined up the right way, okay? So to process a file, this is what we do in our process file method, right? We're going to open it with a scanner. We'll talk about scanners next, but scanner is basically like, you know, fopen, fgets, fclose, that kind of thing. So we'll open it with a scanner. If there's an error because we can't open the file, we'll just return our -1 flag right there. We're going to make a hash map called index, so we'll talk about hash maps too, but it's basically a hash table. It's a built-in class. We don't have to do any work to make that function. So you create a hash map, call it index. The keys that we're going to use to identify things are going to be strings. Those are the words. And the values associated with those keys are going to be linked lists of integers. That's where we're going to store all of the occurrences of a word. So in a rough sketch, here's what your index looks like. It's a big hash map. And here's, so hashes have key value pairs. This is the thing we hash on. This is the value associated with it, right? Associative array. So what you're going to store here is a word, and what you're going to store here is a linked list, right? The linked list is going to be where each of the occurrences of your word was in your file. So if you have a word hello, and let's say hello occurs at positions 5, 10, and 20, then the value in our hash map associated with the word hello would be a linked list like this. And yeah, you're going to import the linked list class, you're going to import the hash map class. Alright, so this is what you're building, right? You find a word, hello, it's going to have a linked list associated with which has the location of each occurrence of the word hello. And we don't have to think about sentinels anymore, because we're just going to use a linked list class, and we're going to say add something to the end of our linked list. So when we get the first thing, that's the first location that's been stored. Is there a sentinel somewhere under the hood? Maybe, maybe not. Okay, we're gonna completely not think about sentinels. All right. So open the file using a scanner. Make a hash map. Keys are strings. Values are linked lists. You're going to need some kind of running position counter. Okay, so just an integer that every time you get a new word, you're going to increment that integer. Okay, so initialize your position counter to 0. We're going to read words from the file, and we can do that using the has, next, and next methods, which we're going to talk about in a few minutes. Right, but these are methods as part of the scanner class. So this will tell us if there's another word, and if there is, this will give us the new word. And then we're going to clean it up by calling our cleanupWord method. And you're going to want to make sure the word's not empty after you clean it up, because if it's a word containing just, punctuation marks, when we get rid of all the things that aren't letters, it'll be an empty word, and we don't want to add an empty word. So assuming that it's not empty, we'll increment the position counter, and then you're just going to call add reference, right? And you're going to say word, comma, position counter. And that should take the word and glom it into this data structure and put that position counter at the end of that word's linked list. All right, and you're just going to keep looping on that until you're out of words. When you're out of words, close the file and return true. All right, so most of the work happens inside add reference. That's the thing that actually adds stuff to this data structure. All right, so how does this function? Suppose you're going through, you've got a position counter. Let's say you're up to position 5. So you've indexed 4 words so far. And you read the next word and you clean it up, and your word is, let's go with pig, because it's that kind of morning, right? So what do? You look in your hash map for the word pig, and you don't find it. So you add that, and you construct a new linked list, which will be, empty to begin with, and you add that position count. Well, let me make it 25 so we don't conflict with these. So you add that new position count, and you're done. Okay, you come to the next word, which is dog, and you look in your list, and that's not found, so you increment your position count to 26, and you store dog somewhere in your hash, and you make a new linked list with a value 26. Now let's say you find the word pig again. Okay, increment your position count. Look for the word pig. It's already in there, so don't create a new linked list. Just take that linked list and add a 27 to the end of it. Put in a new node, 27. And let's say you're going on and you get up to, word 45 and you find dog again. Well, look in your hash. If you find the word dog, take the corresponding linked list and just add a 45 to the end. And keep going like that. All right. So you want to have a really good mental picture of this before you start writing code. If you're clear on what you want to do, this is like 2 lines of code to make this happen, honestly, right? We can look for a word in our hash map by just calling, a method in the hash map class. And if it returns, that is found in the hash, we can say, give me the value for that. That's going to be a linked list. We can take that value and say dot add, or add last, right? The position count, and it'll glom it onto the end of that linked list. And if it's not found in there, we go ahead and we insert it with a new linked list, right? We can put the constructor call right inside the method call to add this key to the hash map. And then, again, we take the linked list that we just constructed and we call the add method to add a node to the end of it. Alright, so that's what this is referring to here. Add reference functions as follows. If the word is not in the index, add the word to the index along with an empty linked list. And then, whether the word was in there to begin with or it's in there now because you just added it, find the linked list associated with the word and just add the position counter to the end of that list. Alright, cleanupWord can just be a simple for loop, right? Just go through character by character and build an output string. So let's do this. CleanupWord. So cleanupWord. Here's your input, right? So set your out equal to an empty string. This will iterate through each character of your string, right, from 0 to the length of your string minus 1. And use the character at method. So get the character at position I. We can call that C. See if it's a letter. If C is a letter, then just append it to the end of your output string.
Hey Nick, we can't see what you're writing.
Thank you. Alright, so cleanupWord input. Set an output string to be empty. Iterate over all the characters in your string, just a regular for loop. For each index, right, use your character at method in the string class to get the ith character of the string. I'm storing that in a character C. And if C is a letter, append it to your output string. Right? Do all of that in a for loop, and when you're done, just return your output string. So if your input was DON''T, your output starts off empty. You grab the D, it's a letter, so you append it to your output. You grab the O, that gets appended. Grab the N, that gets appended. When you grab the apostrophe, it's not a letter, so don't append it. You get to the T, that's a letter, append it, you reach the end of your string, there's your output. And while you're at it, maybe do a 2 upper somewhere in here to convert it to uppercase. So we could, let's take a look at what we have here. So the string class has this character at method, which will give us, character at some index. It also has a 2 upper, so we can say 2 uppercase on the string, which will return an uppercase version of the string. So we could do something like, in equals in dot 2 uppercase. Or we could say in dot 2 uppercase dot character at. And the character class has a method called isLetter. Right, takes a character and it gives us back a Boolean. So we can use that to see if we've got a letter or not. And we can also make characters uppercase. So we could say in dot character at I dot 2 uppercase. And you could do all of this in one fantastic if statement, something like if in dot character at position I dot 2 uppercase, well, we don't need to do it uppercase, dot is letter, out equals out plus in dot character at I dot 2 uppercase. Right? Now you can use temporary variables if you want, but if you start kind of trying to push yourself to think about things like this, right? I don't really need a character C equal to the ith character. Right? The only reason I'm doing that is because I want to append it to my string. But I can just say out equals out plus my input string, character at I, converted to uppercase. Right? You don't have to do that in one line, and sometimes it's going to be more confusing to do it in one line. But in this case, right, this is exactly what I want. I want the uppercase version of the ith character of my input string. I want to know if I have a letter at the ith position of my input string. And when you shift to sort of thinking about it like this instead of like this, which is more C-like, right? It puts you in this object-oriented mindset where you start to think of these classes as what they actually are, which is this whole little factory of data and code dedicated just to processing whatever that type of object is, a string, a hash map, a linked list, and so on. PA2 does seem simple and complex at the same time, absolutely. And I made a comment in the beginning of it. My version of this that I wrote was like 80-some lines. And about half of that was either totally blank lines or lines with just a curly bracket on it. So, about 40 lines of actual code to make this work. Right? Which doesn't mean you have to shoot for 40 characters, but if you're finding yourself with a 500-line program, you're probably doing work that you don't need to be doing. Right? So most of the hard work is already done for you because we have hash maps, we have scanners, we have, things like isLetter, we have linked lists. All of those things are available, and we're going to use them. All right, so sample main program, and Oh man, rip off. Why can't I get down to page 4? Oh, I hit a character I shouldn't have hit, man. And I switched into like continuous scroll mode. There we go. All right. So sample test code. This is all available on the Linux server, okay? There's a sample program under pa2test.java. There's a sample input file, testfile.txt. And there's a sample class, indexer.class, which should be a good implementation of this. So sample way to use this, right? Construct an indexer, and let's look at what ind looks like. Let's call its toString method, okay? And let's look for the number of instances of the word test. Well, I haven't built an index yet, so this should return -1, right? Same thing if I look for the location of the word test, or I ask for the number of words. Okay, if I try to process a file that doesn't exist, so assuming you don't have a bad file in your directory, right, all of these things should come back -1. Okay, if I open a good file, like testfile.txt, right, my status should come back to be true. And if I just print out that index, I should get a nice output of my entire word index. Okay, if I ask for the number of times that this word appeared, which it doesn't appear anywhere, I should get -1. If I look for the word test, and so on and so forth. Okay, so here's the test file. So this is a test, so it is, etc., etc. And the good output, if I just print the index object, this is what I get out. It's a really nice human-readable synopsis of the data. For example, the word this occurs at positions 1 and 21. The word will occurs once at position 23. The word so occurs at positions 5, 8, and 12. All of this output comes from simply calling the toString method. Right? It comes simply from this one statement. After processing good file, ind equals plus ind. The toString method of ind produces this big, long, beautiful string. And again, it takes you no work to do that. Once you've got this structure built up, all you're going to have to do is basically return index.toString. All right, so looking for instances of the word test. The word test appears at locations 4, 20, 26, 27, 28. So if I say where's instance 0, it's 4. Where's instance 1, it's 20. Where's instance 4, that's the 5th location, it's 28. And if I look for anything beyond that, it tells me it's not, doesn't exist. Right, and then if I ask for the number of unique words, which I do by calling index.numberofwords, it tells me 19, and there should be 19 unique words in here. All right, so grading. So put this in a subdirectory under your GitLab repo, subdirectory called PA2. Okay, and you need to have an indexer.java. I'll do my own main program. You can put main programs. You can make other classes if you want with a make file and so on and so forth. And then pretty straightforward rubric. Downloadable and compilable is 20 points. If you have an indexer class, it's 5, and so on and so forth. So you can read through these. Ask me if you have questions about them. Recommended approach: start with just a bare indexer class and make a very simple version of process file, right, which just reads words and prints them. Okay, don't worry about indexing. Don't worry about cleaning up, right? Just read words and print them. Why? Because this gets you the basic class. It gets you a constructor. It gets you a method, right? and it lets you sort of build this outside framework, this skeletal structure that doesn't do what you ultimately want it to do, but it gives you something to add on to, something to build from, right? And then start playing with hash maps. Put your words into a hash map, and print out the contents of your hash map. That gets you working with that structure, and then start adding in linked lists for the values, and so on and so forth. Let's see. Cool. Yeah, glad the main programs help. I think it's nice to have something that especially with this, which is, you know, theoretically very little code but a lot of functionality. It's nice to be able to know if you're on the right track or not. So having a target main program. Yeah, never be afraid to break your programs. That's where good stuff comes from, right? You gotta break down and build up. That's programs in life. All right, so we've got 13 minutes. Let me start talking about hash maps. We've talked about a linked list. We looked at a linked list class. Let's look at hash maps. So hash map, it's a generic. You construct it with two types of things, which are called a key and a value. And remember, the basic setup here is it's an associative array. So we have these key value pairs. And for each key, we have, you know, some value associated with it. So you're going to construct a hash map, and in this case, the type of thing that the key is just a string. The type of thing that the value is a linked list of integers. And you can do this all in one place. When I construct my hash map, I'm going to say, you know, hash map, angle bracket, string, comma, linked list, angle bracket, integer, close angle bracket, close, equals new hash map, angle bracket, same thing, paren, paren. All right, once you have a hash map, what can you do? You can see if it contains a particular key. So when you find a word in your input, you get it back from, you know, cleanupWord, and you want to know, is this already in the hash? Index dot contains key, parentheses, you know, word. And if it comes back true, you know it's already in there. If it comes back false, you need to add it. All right. How do we add to our hash? We use the put method. So you could say put key, comma, new linked list, angle bracket, integer. Yeah, it's got some hash function inside that we don't worry about, but there's something that it's doing internally, you know, to implement a hash in the style that we talked about in 222. Is it a big array? Is it a linked list? Don't know, right? But we get to interface with this through this front end as an abstract hash, which basically says we can search for things by saying contains, we can add things by saying put, and we can retrieve things by saying get, or fetch, or something. Or something. Yeah, I thought it was get. Oh yeah, get right there. Okay, so we can say, you know, index.get parentheses some word, and the return value from that will be for us a linked list. And so you're going to end up writing things like this. And let me write it, and then I'll show it to you. So if your hash map is called an index, you're going to do something like index.get, and you're going to put in, let's say that your cleaned up word is stored in Word. You're going to say index.get word. That's going to be a linked list. And if you look at the linked list class, you want to add to the end of your linked list, you can do that with just the add method. So you're going to end up with something like this, right? That's your whole hash map. You call the get method with the word that you're trying to add to your hash map. This is a linked list. Linked lists have an add method. Pass that add method the position of that word. This one statement goes to wherever that word is stored in the hash map, finds a linked list, moves to the end of the linked list, makes a new node, sets its data equal to that, and sets up the previous last node to point to that new last node, sets the new last node to point to null. You get all of that just for this. So you're going to be writing statements that look like this, perhaps, that do a lot of stuff, but really you're just telling the system what to do. All right, let's see. What else do I need to tell you? Scanners. So we haven't gotten to scanners in here yet. We got to it in the afternoon class on Wednesday, so there's video on there. But let's do a quick run through on scanners. Scanner is a way to read input, okay? And it works like this. All right, so we have to import. All these things have to be imported. So when you look at the documentation for any of these classes, it will tell you the name of it. So like Java utility scanner or java.util.linkedList or hash map. So those get imported. And basically you construct a scanner, and for testing purposes, you can start off with system.in. That's standard in. So make a scanner associated with that. That gives you, some object. I'm calling it SC. And basically, you use a pair of methods. So for example, I can say, well, SC has next line. Let's set temp equal to sc.nextLine. And then let's print out the value of that. So there's pairs of functions, methods in the scanner class. So if you want to read a line at a time, you can say has next line, which tells you is there another line of input available. And if there is, then you can call the next line method, which returns that entire line. So everything up through the end of line character, the new line. To read a word at a time, you can simply say has next. Way up here at the top, has next. Okay, if it has another token, and if it does, then next will give you that token. So let's tokenize some input. Well, sc.has next, temp equals next. And let's go ahead and make a word count. Alright, so here I've written half of your PA2 for you right here. Well, the scanner has a next token. Let's read that into temp. Let's increment our position counter, and let's just print out word such and such is temp. And I'll hit a Control D for the end of the file. And there you go. I can run it on itself. Alright, and there's my program broken up into a bunch of words. So you can see what this has next and this next method are doing. They're basically taking things separated by white space. Right, so import this, class this, and so on and so forth. Now if I clean these up, this would look like main string, this would look like args, this would be completely empty. right? Because there's no letters in here. So that's the scanner class. We'll talk on Monday about how to read in from a file, but for starters, you know, you can just read from standard in, and you can redirect with a less than symbol, and that'll get you on the air. But chances are in the afternoon class we'll get to talking about how to read from a file. It's like 2 statements. Well, we might have enough time. Yeah, we probably don't. But you can read from standard in to get started. But then we're going to want to look at the file method. That's always the question, right? So we can construct a file with a path name and use that in a scanner class, but then we need to talk about exceptions. So yeah, do just redirect from standard in to get started on this. And we'll do a proper treatment of files on Monday, which includes talking about exceptions. All right, and that should be everything that you need for PA2. So that's a whirlwind discussion of it, I understand. But my suggestion, one way to break it down would be this: you don't have to do it like this, right? You can do it whatever way makes sense to you. But if you're not sure how to start, I think this is a reasonable set of steps. All right, good. Any final questions? I've missed like everything that's been going on in chat. Well, we got some cool ASCII in there. All right, awesome. Have a great weekend, and I will see you on Monday. I'll get your PA1s graded with some feedback, probably Saturday. All right, cool. Have a good one. See you next time. Thanks.